Hi guys, I hope you guys are all doing well. And today we are going to pick a very funny problem. Funny because it requires some observational skills. It is just some array manipulation, and you get your answer. But for that, you have to have some observational skills and just apply the observations that you found, and you will get your answer. You just have to implement it. So let's look into the problem, and happy coding. So the problem name is next permutation, and let me describe the problem for you. It says that implement next permutation, which rearranges numbers into lexicographically next greater permutation of numbers. And if such an arrangement is not possible, it must rearrange it as the lowest possible order. The replacement must be in place, so this line is very important for us. The replacement must be in place and should use only constant extra memory. So we cannot create an additional array or hash map or any kind of data structure because we need to do it in the constant extra memory. So let us first see like what the problem demands of us. So you can see that we have been given an input like 1, 2, 3, and we need to create the next largest permutation of the numbers given to us in the array using the same digits. Now the next biggest number that I can form with the given array is 132 because I've been given 123. I can just swap the last two digits and I can get 132. Similarly, let's see if our theory of swapping the last two digits um, does it apply to all the test cases. Let's see. So the second example is 321, which is like all of the numbers, they are in descending order. So the next greater element is not possible because we have strike the combination which forms the greatest possible number which is there using these digits. So in that case, we have to use the second point that we have been given. Like if such an arrangement is not possible, we have to rearrange it as the lowest possible order. Like this 1, 2, 3. Okay. And similarly, we have the third case, which is like 115, and here we can see that it is in ascending order. So we replace the last two digits and we found 151. And I mean, the test cases are not, I would not say that test cases are very descriptive because we have to observe a few things. Like I said, this problem is all about observation. So let's draw out some observations. Okay, let's look at the constraints also. So it will involve 0 also in the numbers. Okay, that's fine. Yeah, our observations will hold for any of the numbers actually. So let me draw a quick observation for you. So let us say let us take one random set of data. Let's say we are taking 9, 6, 5, 3 and 2. We will be working on this data structure, but we will be working on this data set, but let us first write down the observations that we already know. Suppose we have been given an array in an ascending order. Ascending order, then we just need to swap the last two digits. Okay, what if we have been given in descending order? Then we just need to sort and return the return the ascending order of the array, because if you remember the last point which said that make the smallest possible combination if there is no such possible combination available. So what about the other cases? We have to make an observation for the other cases. Let me use this data set and draw the observation for other cases, and we will see how we can apply that other case observation to all the kind of data sets that we have. Let us see. So I'll write down the data set again here, 96532. Let me just compare whether it was correct. Yeah, that's the one. Okay, so I'll draw a kind of a graph describing like how the variation of the value of the number is happening inside the array. So first we have a 9, then we are going to 6, then again 5, then 3, and then 2. So this is like entirely descending. We just have to return the ascending form because that is the only possible combination now as per the question. So we will return something like, I mean not something like, but exactly like 2, 3, 5, 6, 9. So the graph goes like this. Now let me take a random combination of these digits only. Let me take 5, 9, 3, 2, 6. Okay. Now we have a 5. Let's say 5 is over here. Now 9 goes over here. 3 will come below 5. 2 will again go below 3, and 6 will be somewhere between 5 and 9. So we have a graph like this. Now we need to make the next greatest number that is possible using this data set that has been given to us. So we have to make some observations. Okay. So we are standing at 6 and we encounter a 2. Then we have 3, then we have 9, and then we have 5. Now just see this. We have a greater number over here and then we have a smaller number. Obviously you can swap these two and make the next bigger number, because here we observe the pattern that it is decreasing. Correct. So we found a first dip basically. We have to look for that first dip only. Now once we swap this, we have our number with us, the next bigger number. Now let us try on this. Okay, so we have 5 over here, 9 over here, 3 somewhere over here, 6 again in between 5 and 9, and 2 will be below 3. Now you can see we have an upward going trend over here. If you remember, like I said, we have to find the first dip. In this data set, we found it in the first pair itself. But here, it is not in the first pair. Let me write the numbers as well. 2, 6, 3, 9, and 5. So here, we did not find it in the first pair. And the next possible pair that we have is a dip, which is this. Now you must be thinking that, okay, I'll swap these two and my answer is sorted. I will get the answer, but that's not the case. Why? Because if you remember, we are climbing a hill over here. That means there are values which are lesser than this after this. So we need to swap this number with the value which is just larger than this but smaller than this. I'll tell you why. Because we have to form this. We have to form the next greater element, next greater number, which is smallest, but still greater than the data set that we have been given. Okay, so like I said, we just have to find the just larger number than this, and we have to replace. So in this case, obviously it falls over here, but just imagine if we had over here, if we had like a 4. Suppose if we had the data set like 5, 9, 3, 6, 4, 2. Suppose. Now we have to look for the just larger number than 3 after 6. So we will start from the right and we will traverse to the left and we will encounter 4. What we are going to do is we are going to swap these two. So now we have 5, 9, 4, 6, 3, 2. Now you must be saying, okay, we got a next greater number, but this is not the case. So if you see, this can be further decreased and we can get a solution like 5, 9, 4, 2, 3, 6. So basically we are reversing these. Now reversing these, or you can say we are sorting this as an ascending order, but I would still say we are reversing this because if you see, we are not breaking the upward trend from right side. That is, these numbers 6, 3, 2, they are in the descending order only. So we can just reverse it and make it ascending order. And this will hold true for every case. Let me show you some more examples. One last example I'm going to show you. And if you have any doubt, if you have any test case that you think that it will not work for, just let me know in the comments. We can sort it out as well. So let's see for a case like 4, 4, 8, 6 and 4, 8, 6, and suppose I have 5 and 4 again. Let's see. So I have my 4 here, 8 goes over here. Then we have a 6 between 8 and 4, 5 somewhere over here, and 4 again over here. So we have a 4, 4, 5, 6, and 8. Now if you see, there is a upward trend and there is a dip over here. We have to find the first dip, like I said. And the first dip is happening at this 4. Now we have to find the number which is just greater than 4, but it is after 8. So we'll start from right again. And we find that, okay, 5 is just greater than 4 and it is after 8. We'll just replace it and we have 5, 8, 6, 4, 4. Now this can be further reduced and we can reverse it. Why? Because still the descending trend from 8 towards the end is still valid. So we can just reverse it and we will have 5, 4, 4, 6, 8, which is the next greater number. So this is the solution. Basically this is the logic, and this was the observation that I wanted to explain basically. And this observation holds true for ascending also, because we will find the first dip in the last 2 digits. We will swap them and we will just apply reverse, which is not effective on the last digit basically. For descending, that is just a special case where if we don't find a dip at all, we just have to return the array in ascending order. We just have to reverse it. So I hope you guys understood the logic. Now let's dive into the code. So let's dive into the code now. Okay. So I'll write the comments and so that they will help me think clearly when I'm coding. So the logic is that we need to find first dip, then we need to find, that's okay, I'll write in point form, then find the element just greater than element at dip from the end. Put this in brackets so that it's not getting confused. Okay, now swap the two, reverse the array from the dip plus 1 index to the last. Okay, so we have our kind of pseudo code, and also I explained the logic. So let's just dive into the code now. Okay, we are doing it in place, so I'm not taking any extra array for result. I'm just going to do it in the nums array itself. So first we need to find the first we need to find the dip, and also we need whether we found a dip or not, because in the case of descending array we won't find any dip. So let me just take 2 variables, int dip index. I'll mark it as 0 initially, and I'll take a boolean also, found dip. I'll make it false because I'm initially saying that, okay, we didn't find a dip at all. I'll start from the last. I'll make it as iter. I'll run it from the end of the array, because if you remember, we were going from the end of the array to find the dip. Now iter will be greater than 0 because we are going to look for a pair of elements. So I need to look for the 0 also. So when I'm in the 1, I have to look for the minus negative 1 also. I mean 1 minus 1, which is 0. So if I'm on 0, it will try to access negative 1. which is like array index out of bounds, so I don't want that. So I'll go till iter greater than 0, iter minus minus, and then I'll look for if I'll encounter a dip only when my nums of iter is greater than nums of iter minus 1, and this is where I find my dip. So my element at the dip will be the element at the index iter minus 1. So my dip index becomes iter minus 1, and yeah, I did found a dip, so I'll make this as true. Okay, and I'll break it. Why I'm breaking it? Because there could be a possible scenario where there could be elements, there could be a pair before that as well, but we don't need to go there. So we need to break where we find the first dip, so that's why I'm breaking. So we'll come out of the loop and we'll check if we found a dip. So if we did not find a dip, sorry. So if we did not find a dip, then that means the entire array is in descending order. We just need to reverse it. I'll just I'll make a placeholder function. I'll code that function after I code the next permutation method. But yeah, I'll just put it over here for now. And I want to reverse the entire array. So I will be passing 3 parameters, basically the array that I want to reverse and from where to where. And I'll just return. This is a void, so I'm just returning. I don't want to execute any further. But if that is not the case, then I'll start again from the last, of course. And this time I'll include 0. Now I'll look for if my dip index is, if my value at the index iter is greater than the value at the dip index. So just greater than. So we are finding the first greater, if you remember. Okay, yeah, I'm doing it correct. Just thinking, yeah. So this is this. So once we find this, we need to swap these two. So I'm going to do it. I can do it in place. Yeah, let's do it in place. Nums of iter equals to nums of iter plus nums of dip index. So my nums of iter, it contains the value for like it contains the addition of both. So this is just plain simple sorting. What we say? This is just simple swapping. Sorry. Now we need to get the value of dip index into nums of iter into dip index. So what I will do is I'll subtract dip index from iter. So now I got the nums iter into nums dip index. Now in nums of iter, I just need nums of just a second, I did something wrong over here. Okay, now in nums of iter, I needed nums of dip index. So what I will do is nums of iter minus nums of dip index. This is just swapping in place. So this is simple, yeah. So let's we swapped the element. Now we just need to break again because we have done our job. So this loop has served its purpose. We are just breaking it, coming out, and now what we need to do is from the dip index plus 1 to the end of the array, we just need to reverse it, if you remember. Okay, now we can either do a return or we can do nothing. So basically this method expects us to return nothing. I'm putting a return statement over here because I don't want the program to execute further. Now what remains is that we write our placeholder method, which is reverse. Let me see. private, which is returning an array, of course. Yeah, private int reverse, and it is expecting an array to reverse and a start position and an end position. Now what I can do is I can just put a while loop over here, and I can say that hey, I need to reverse this, so basically I need to swap. I'll take a temporary variable over here, and or I can do it in place, but yeah, I've done it on in place, so let me do it with a temporary variable as well. To rev into start, and to rev into start equals to to rev, basically to reverse of end, and my to reverse of end will contain the value which is being held by temp. Now I need to return my to reverse array over here. Okay, so the program looks good. Let's see if it runs well. Let's see. Okay, as expected. It is a typo, I think. Yeah, dip index. Yeah, okay. Okay, it worked fine for one test case. Let me use the example test cases, and we will also pick one of the test cases which we have gone through in the logic. It says time limit exceeded. Okay, let's see why. Okay, I've done this, and I can ask it to go through, go till the break dip index. And what else we can do? Is there a possibility of infinite loop? I don't think so. Let's see. Oh man, again a typo. Still saying it is time limit exceeded. Why? Reverse the nums and start. Oh, my bad. Wow. I don't know how it ran for the other arrays, but man, yeah, this was the infinite loop because I was not decrementing or incrementing start or end. Wow, such a trivial mistake. So these all ran fine. Let us submit the code and see. Okay, perfect. Yeah, it worked. Yeah, this is all for the video. I hope you enjoyed it, and I hope it was valuable for you. Thank you for watching, and keep coding. Bye. I messed up. I messed up.